Example 2 for composite transformations. So we're given our algebraic rule. I'm going to bring, well actually it's already over here in the table, so let's go ahead and apply the algebraic rule to figure out the remaining values in our table. So our first value needs to be y plus 5, so that would be 0 plus 5, and then 0 plus 5 again, and then we have to figure out what plus 5 would have given us 0. So that would have to have been negative 5. And then, let's see, we'll go ahead and do the second part in red. We have negative x plus 5, so we'll do negative 0 plus 5. We'll do negative 13 plus 5. And then negative blank plus 5 would have given us 12. So 7 plus 5 would equal 12, and so we need to have a negative 7 that would fill in that blank for our problem. And then, let's see, did I accidentally erase this number right here? We had a negative 5. Maybe it just didn't show up when I wrote it a minute ago. Alright, so let's fill in our table. So we have negative 5 plus 5 gave us 0, and then negative 7 was the number we needed for the y. And then for our image values, we have 0 plus 5 would be 5. Negative 0 plus 5 is still 5. 0 plus 5 is another 5. And then negative 13 becomes positive 13 plus 5 is 18. Alright, so I'm going to clean up a little bit of my handiwork there. Now, let's go ahead and put that on the graph. So I'm going to graph the A, B, and C for my pre-image. So A is at 0, 0. Notice I've made my graph on a scale of 3, and I shifted the x-axis down a little bit to accommodate for all of my points. Then B is at negative 13, 0. So negative 3, 6, 9, 12, a little past that would be about right there for point B. And then C is at negative 5, negative 7. So negative 5 is like 1 and then 2/3 of a box, and then down 7. So it's about right there. Connect the dots, and then let's graph the image in green. So we have 5, 5 would be 1 and then 2/3 of a box, and then up 1 and 2/3 of a box is our A prime. It's always good to label our points. And then B prime is at 5, 18. So 5 and then up 6 boxes would be B prime. And then C prime is at 0, 12. So that's just up 4 boxes for C prime. Alright. So now it looks like from our steps that went along with our algebraic rule, we can kind of tell what happened, so we'll be able to write our verbal description. If we have y negative x, that means that we had a rotation of, it rotated 90 degrees, because it would be y negative x in this fourth quadrant, or you just have to memorize those rules. So it rotated 90 degrees clockwise, or 270 counterclockwise. Either one would be okay, but you need to name one or the other. So counterclockwise, and then it looks like from this description that it went to the right 5 after that, and it went, oops, sorry, let me hide that, I don't know what happened there. And then right 5 because it added 5 to the x. And then it added 5 to the y, which made it go up 5 as a translation. Okay, so let's just put all that together in a nice way to put everything like we've been doing in this unit. So let me grab the color I always use, is about dark blue. So let's see. Given triangle ABC, list out our points. So with A at 0, 0, B at negative 13, 0, and C at -5, -7. So the first thing that happened is a rotation. So let's say rotate triangle ABC, and I'm just going to say the shortest distance. So 90 degrees would be shorter than 270. So 90 degrees clockwise. And then translate triangle ABC, right 5 and up 5. Alright, so that's it for example 2.